Good morning, everyone. My name is Nathan Heston. I'm a trainer here at Briggs & Stratton Energy Solutions, and I'm looking forward to delivering this training together with a colleague from Sol-Ark. So Quinn Weber is the product manager for the residential side of Sol-Ark. Good morning, Quinn.
Morning.
So as we wait for everyone to join with us this morning, I just want to remind you that there is a Q&A session, and I will do my best to try to monitor the Q&A. You'll be able to ask Quinn and I questions as we go through the presentation. Don't feel like you have to hold the questions to the end. I think we all tend to learn best when there is some back and forth, and those questions are often helpful. So please do feel free to use the Q&A. We are not able to unmute you in this webinar, but we are able to interact with you through the Q&A. So again, welcome everyone. We're going to be talking about communications with energy storage systems together with Sol-Ark inverters and SimpliPHI batteries. We'll also be talking a little bit about integrating Briggs & Stratton generators into energy storage systems and how they can complement batteries and how batteries can increase the efficiency, reduce runtime, increase lifetime of generators, etc. And one of the nice things about Sol-Ark is it's probably the best inverter on the market to do integrations of generators together with batteries. So we'll be talking about that. So let's go ahead and get started. You may or may not have heard, but Briggs & Stratton has released a new SimpliPHI 6.6 stackable battery. And this battery goes together very quickly. All of the communications are handled through the stacking feature of this battery. We have a rapid stack technology that we've leveraged to handle the communications and the power cabling. So it's very easy assembly, which makes for a much quicker installation time. And we are recommending this battery specifically with Sol-Ark inverters, and in particular, it's designed around providing those power needs of a Sol-Ark 15K. So a single stack of these batteries is capable of providing the full power needed by a 15K to give that full performance. Additionally, a nice benefit of that Sol-Ark 15K is that 200 amp pass-through. And so we might be talking about that as we go through it, but we also have packages in which we're recommending the 12K from Sol-Ark as well. So one of the things I'm excited about in doing this joint presentation with Sol-Ark is that we've got two American companies, right? Sol-Ark from Texas, Briggs & Stratton, a 115-year-old American company headquartered in Wauwatosa, Wisconsin. And I really enjoy working together and providing a solution from American companies, offering American tech support, offering good customer service. And I think that's one of the places where we both shine. Briggs & Stratton has long done manufacturing in the US. SimpliPHI batteries have long been manufactured in Oxnard, California. And so we have a West Coast customer base, but that's growing across the country. And so we're excited to be introducing this partnership broadly. So we're going to talk a little bit about these packages in the future, but one of the questions you often probably get from homeowners as you're talking to them about battery backup is, how long will my house be backed up? How many hours of backup will we get? And that, of course, depends entirely on the number of loads that they're doing and the size of that battery. So if we give them a battery of a particular size, it might give them 7 hours of backup. It might give them 27 hours of backup, and it really depends on the load. But in order to address that question and try to do it in an easy way, we're using these two packages here where we're assuming that with a Sol-Ark 12K, they'll back up about 75% of the loads of their house. And if we do it that way, they would get on average, using the average continuous load in the US of 1.23 kilowatts at any given time. That's a year-round average. They would get about 7 hours of backup per 6.6 module. So the package that we're recommending with a Sol-Ark 12K and two of these 6.6 modules, you get a little over 13.3 kilowatt hours of energy in that battery, and that should last for about 14 hours. Now, when we go to a whole home backup, they're backing up 100% of the loads in their house. And so instead of 75% of that 1.23 kilowatts that they're typically using, they would be using that full 1.23 kilowatts of power. And so you get 16 hours of backup when you add a third battery there. So we're going to use these packages to try to educate the homeowners, but we understand that most installers realize that there's going to be a difference in amount of backup time for customers. So I'm going to start by talking about what an energy storage system is. And just a high-level view, most of our customers know this already. Most installers know what an energy storage system is. But I'm going to point out that at the heart of an energy storage system, we have a high-quality inverter, or we should have a high-quality inverter. And software makes a huge difference for this. And so we're recommending the Sol-Ark inverters in these energy storage systems. And those inverters at the center of an ESS system are managing the flow of power. For generator customers, the Sol-Ark inverter behaves very similarly to a transfer switch, right? Regulating power that could be coming in from generators, could be going to batteries, or coming in from batteries, coming in from the grid, even going out to the grid, could be coming from solar. But not all of these components are needed. Many of our customers are choosing to just have an inverter with batteries to have battery backup, but not necessarily integrating solar, which has more been the typical approach. Quinn, is Sol-Ark seeing that with other companies, with other installations as well?
I mean, so my background is as an installer in California, and we actually took some customers that were fully off grid, and I can think of one customer specifically who had a well. He had an old Xantrex inverter, and his well, the Xantrex inverter was not powerful enough to power his well, so he would go out and fire his generator manually, run his well off of his generator, and then he'd go out and turn off the generator when he needs to, and so that he would fill his water tank. And by putting in a Sol-Ark inverter with a battery system, we were able to make his well run just enough to recharge his battery, or have his generator run just enough to recharge his batteries, and then use those batteries to actually power the well. So he reduced his generator runtime significantly. So it's exactly what you're talking about. He used the Sol-Ark inverter as a energy, or a energy management device, rather than necessarily needing solar.
Thank you. Yeah, and that's one of the things I like about Sol-Arks is the ability to have a lot of control and energy management. So we're going to jump through some of that. I do want to highlight our Briggs & Stratton generators here. We traditionally have had power management systems through our transfer switches, now going into the SimpliPHI 2, etc. We have load shedding modules, but it's done a little bit differently through the Sol-Arks. And of course, we can integrate the generator into the Sol-Ark, where the Sol-Ark can really take control. So I'm going to highlight two different features here, two different installation options. And one is a partial home backup system. And so with a Sol-Ark 12K, you are limited to about 9 kilowatts of maximum sustained power. It can surge for a short time to start things like a well pump. But in general, you wouldn't be able to back up your whole home with a 12K. So the 12K has a limited pass-through of about 63 amps, which means that some of your large systems, maybe a large central AC system, you wouldn't be able to run on that 12K. And so you would do what's called a partial home backup, in which you pass some of the current through the main panel to a critical loads panel, have a battery, potentially integrate that solar as well. And then in a grid down situation, your batteries would supply power to that core loads panel. With a whole home backup, it's different. There is a utility disconnect, but all of the power can pass through that Sol-Ark 15K. That's the advantage of having that 200 amps of pass through on the Sol-Ark 15K, and then you would back up the entire loads panel of the house. So in a grid down situation, yes, you are disconnected from the utility so that we're not backfeeding maybe from our solar, But now we're still backing up the entire house. So two different options there, and the installation is a bit different. Run times are obviously different if we're not backing up the whole home. Of course, load management can be done, and even the Sol-Ark, if you're not using a generator, you can use that grid port, or sorry, that generator port on that Sol-Ark 15K to actually run a sub panel where you could do managed loads. I'm going to show just briefly, this is not a training on how to wire these systems, but just briefly what these two systems would look like. So with a Sol-Ark 12K, we'd be utilizing a two stack of our 6.6 batteries or larger. So that's really a minimum if you want that full power out of a Sol-Ark 12K. And the wiring diagram would look essentially like this, where you see that main panel, but you also have an essential loads panel on the right side. We are able to pass through, I believe it's 63 amps through that Sol-Ark 12K. And so you could have all of your power coming from that main panel, just powering the essential loads panel until there's a grid down situation. Or you could integrate solar through that inverter and have solar contributing and even charging the batteries and powering the essential loads or feeding back to grid. Changes a little bit with a Sol-Ark 15K. I believe it's a much simpler install to do a whole home backup just because we don't need to move loads over into a separate loads panel. But we're essentially showing you these slides because we'll be including the slide deck to you and sending that out by email after the talk. Quinn, any corrections to make here, or do these wiring diagrams look all right?
This all looks good. The only thing is, I see at the bottom in the 3-star match electrical service for 100 amp service recommended service / main panel upgrade. You can pass 100 amps through a Sol-Ark inverter just as easy. You can pass 200 amps. So, you can back up just like you could back up 100 amp service with the 24 kilowatt generator. You could do the same thing with the Sol-Ark 15K. But these look correct.
Great. So thank you for that. And I actually wanted to talk just a little bit while we're here on the PCS control that Sol-Ark offers through their software. Typically with 120% rule, you are limited in how much you can backfeed to a loads panel, right, based on your busing. And I know that you can get specialized buses that are larger. For instance, if you're doing a 100 amp panel, right, you can get 120 amp buses on that. But what does PCS control allow us to do with Sol-Ark?
So PCS is part of the CRD of UL 1741, and what it allows you to do is basically limit the amount of backfeed to the grid while still allowing us to push a lot of power to your loads. So for instance, on a 100 amp panel, you're only allowed to push 20 amps of power into that panel. But when installed with our CTs around the main feeds, so our CTs are dynamically measuring the amount of current that's going into that busing. You can actually set the inverter so that you make sure that busing is never being overloaded. So with that, normally a 15 kilowatt inverter, if it was, so for instance, a 100 amp panel like we were talking about, 20 amps would be your breaker feeding the inverter. But that isn't going to work on the 15K because we want to feed all 100 amps to, for instance, a critical loads panel or a load panel downstream. We need a full 100 amp breaker there. So by using PCS, you can limit the amount that the inverter is pushing back to the grid or energizing that busing. And that's all part of our grid controls through the regular process of programming the inverter. So if you've installed a Sol-Ark 15K, you may have been using PCS controls and not really known about it. It's an additional certification that our inverter has.
But you don't have to, I guess, with having that certification, the advantage here is that we don't have to limit that connection using breakers anymore. We can use full. Yep.
Exactly. Yeah. There's no limit on the breakers. You can control it through software rather than hardware.
Thank you. So I'm going to highlight the batteries just quickly because it's a new product for us. So this is our first stackable battery. I have to point out that, when I first saw the stackable home grid battery, I thought, wow, this is great, and how quickly it can go together, how quickly it can go, be integrated into a Sol-Ark. So the installation process is greatly simplified. And I still like the home grid. I got chance to install one last week. There are some advantages, I think, that the SimpliPHI battery has over HomeGrid. One of the notable ones, I would just say, is the fact that we can wall mount these batteries. Another one is, this rapid stack technology. We are passing the full communications, the full power through the batteries simply through this stackable connector. So you simply just set the battery modules on top of each other, and then all your communications is wiring is done through this. I also like the fact that the SimpliPHI 6.6 batteries are outdoor rated. So these are a waterproof battery, NEMA 3R. IP65 rating that we can install outdoors, right? We can wall mount, we can install outdoors. It's a lower profile too. So I'm very excited about this battery. I think it will, just like the HomeGrid battery, I think it will complement the Sol-Ark inverters very well and allow a little bit more versatility than what HomeGrid has offered. We're sticking with LFP technology, and we've been able to increase the power output of these batteries. The individual modules themselves are capable of a 1C output, which means a single 6.6 kilowatt hour module can output 6.6 kilowatts of power, and that's a significant increase, right? A typical battery might be C/2 or C/3, meaning it can only safely be discharged in 2 hours or 3 hours. With a 1C charge or 1C discharge rate, these battery modules are rated at a very fast rate. We're looking at 4,500 cycles at a 75% or 0.75 C rate, 100% depth of discharge. So that's actually an improvement for us over our PHI and AmpliPHI batteries with lower C rates. And additionally, so if we do a slightly reduced discharge rate, 100% depth of discharge, again, at a 0.5 C rate, we're looking at 6,000 plus cycles. If you do the math, this is 20 years of use. So LFP chemistry gives you the best number of cycles, obviously the best safety record out there. And so I really don't think anybody should be installing any other kind of battery on homes for home backup. Reason being just the safety factor, right? LFP is just much safer, and we don't need that lighter weight NMC chemistry in this kind of situation. So I don't know about showing this. I typically, I like to remind people that these are just two examples of very similar cells in which the third party, so this is Will Prowse from Do It Yourself Solar, he did puncture tests of an NMC cell and an LFP cell, and he had to drill the LFP cell 10, 12 times to even get it to go into an off gas and to go into a thermal runaway where you're getting off gas. But just a single puncture in an NMC cell just highlights how much more quickly the NMC cells can release their energy. And that's what makes them more dangerous. And for a home installation, even though those NMC cells have an advantage in that they're lighter weight, it doesn't really matter much for a home installation where you're not moving it. You don't need a mobile-based solution. So let me highlight some of the features of the 6.6 battery, and we're gonna talk about how it integrates well with the Sol-Ark inverters. One of the things I like about the 6.6 battery is these LEDs on the front of it. It's nice having an LED indicator that'll let you know the status. There's an LED indicator on each module to let you know that that battery is functioning properly. It's not in too cold of a state, or it's not in maybe a software update or something like that. And there's no problem. There's no problem with the installation. Everything's functioning properly. There's additionally on the top, there's a fuel gauge there where you get to know what percentages state of charge is remaining in the battery. The power button on the very top also has a green indicator light, and when the system is in a state of charging, you'll see those indicators lights flash without having to look at the app. Now, of course, you can look at the app, you can look at the My Sol-Ark app and see things charging, discharging, but it's nice to just be able to see that as you take a glance at the battery as you walk through the garage, for instance. So some nice features there, showing just an image of what that rapid stack connector looks like. Then there's some alignment pins as well to make it easy to just set the batteries on top of each other. So really easy install. Even with the wall brackets, I can install these batteries in about 15 minutes. So that's a pretty big advantage for installers trying to do quick installations. A stack. Go ahead, Quinn.
The other point I want to touch on with wall mount is a big advantage over competitors is we're seeing many more jurisdictions, especially in California or other areas where these are installed in garages, requiring these to be lifted off the ground to avoid impact from vehicles. So if you've got, you really have to consider that in your design, because if you have to go back and add impact rated bollards to your installation, it's a nightmare for installation. So being able to wall mount these is really a major advantage that I see over other batteries.
Yeah, thanks, Quinn. And that's something I agree with you there. So if you are wanting to mount, there are certain locations in a garage where you can mount the batteries without having protection from vehicle damage, right? But for instance, if you are mounting at the back end of the garage where the front of your car would be after you pull in, you either need to have parking ballards, or NFPA requires you to have a parking block similar to what you see in a parking lot, and then that's a tripping hazard when your garage is empty, and that's got to be 54 inches from the wall. So yes, a great advantage for having a wall mount battery is that you can have it up off the ground. I believe the number is 24 inches above the ground, and then you don't need these parking ballards. So that's a nice advantage. I'm going to point out the configurations here of this battery. So we can do just a single stack of these batteries. So if you have a small inverter system and you only need 6.5 kilowatts of power, just a single battery module can deliver that. And we certainly have customers that might only want to back up a few circuits, back up their internet connection, back up their lighting in their house. They don't necessarily care about some of the other features. And so for small inverter systems, a single stack is completely sufficient. For a 12K Sol-Ark, for instance, you would want a minimum to be able to take advantage of that 9 kilowatts of battery power to load of a 12K. You would want to go with a minimum of 2 battery module stack. So a stack, just to let everybody know, consists of a base. It could be a wall mount base or a floor base. Then a number of battery modules, could be 1 up to 3. And then a controller that sits on the top. So that stack controller communicates with each of the individual battery modules and then communicates out with that Sol-Ark inverter. If you want to do a 15K, the minimum we would recommend is having a 3-stack minimum, and that'll deliver that full power to a Sol-Ark 15K as well. We are limited in terms of the number of total stacks that we can run in parallel. We can do each stack of 3 batteries is 20 kilowatt hours, and we can do up to 6 parallel stacks. Of course, you could have 2 stacks of 2 batteries as well, depending on your needs. They don't all have to be stacks of 3. But we don't encourage, for balancing reasons, we wouldn't encourage having a 1 stack paired with a 3 stack. You could do a 2 stack and a 3 stack, but I wouldn't encourage too much imbalance, because that's harder on individual batteries. We need to do a little bit more with the cabling to balance things. Just pointing out, we do have the UL certifications that are listed here on the screen. Again, up to 18 of these batteries for 120 kilowatt hours of overall storage. Those power outputs, as mentioned on the previous screen, but there's also a surge ability in these battery stacks. A single battery can surge to 8.3 kilowatts. 2 batteries can surge to 13.3 kilowatts for 10 seconds, and a 3 battery stack can do 17.5 kilowatts for 10 seconds. And that's, as Quinn pointed out earlier, that's to be able to start those induction motors like the well pump, etc. Also point out here that this battery temperature range is increased. So we can charge this battery below 32 degrees Fahrenheit, and that's not typical. Most companies have a lower range of 32 Fahrenheit. We can charge this battery all the way down to 14 degree Fahrenheit, and that's because of an advancement we've made with the electrolyte that's inside these cells. Discharge temperature all the way down to -4 Fahrenheit. The charging window is a little bit more restrictive, but still giving that temperature range down to 14 Fahrenheit opens a lot more markets. especially for those wanting to do outdoor installations. When this is inside your garage and your garage isn't heated, most garages are going to be within that operational range that's here. Just a quick show of what a real install looks like. So this is here in my shop, not a well curated photo shoot here, but I'm doing an installation. So there is a wall bracket that holds this battery, keeps it from tipping over. The floor back bracket gets secured down, and then you hang this wall bracket, and then those batteries just connect to that wall bracket to, again, prevent any kind of tipping hazard. And I don't have pictures of the wall mount, but a very similar installation for a wall mount option. And these have gone through Category 9 earthquake testing here with UL. So this is showing how those batteries are secured to the wall. Now, this is not the final look. There are cover plates that go over the sides. They just slip into place. But this is showing you how each module is secured to the next module above it or the next part above it. And then they're also secured to the wall. So you get a nice secured installation, and yet it's still quick and easy to do. The cover plates go over those screws. So the side, you don't see the wall mount once this installation is complete, and these just slip into place. And I guess, I don't want to harp on HomeGrid, but I would say that this was another advantage for me when I was installing the HomeGrid batteries. The HomeGrid batteries, you have to secure a couple of screws in each of their cover plates. And I found that it was just a little bit difficult to get those in. So this installs a bit quicker. A nice feature on how those slip-on covers go on the sides. In terms of outdoor ratings, we have 2 batteries that are outdoor rated. We are 4.98. Our newer 6.6 is of course outdoor rated. But I'm going to point out these other 2 batteries here. So these batteries are of course listed on the California manufacturers website. And what that means is if you are a California installer, you can get an extra 20% off by filling out that self-generation incentive program information. Additionally, another thing to point out about these systems is we do have enclosures that we can integrate a Sol-Ark into. And this is an old picture of a Sol-Ark here. Apologize for that, Quinn. But these are essentially plug-and-play systems in which the batteries are all easily connected there. Everything comes in an all-in-one unit, and these can be configured at the factory as well. Another advantage of these battery cabinets is we can integrate heaters into these battery cabinets. So if you absolutely are in a cold environment, you're in Canada, you want to do one of these installations, but you need heaters, ask us. We can integrate those heaters in. But they do need to be ordered that way, so we can integrate heating into these outdoor NEMA 3R enclosures for those batteries. As we get going, I also want to point out, Sol-Ark is probably the best inverter in the market for integrating generators. And we have a full lineup of standby generators, and also these can be warranted for continuous use if you're an off-grid customer. Again, Sol-Ark warranties their products off-grid. SimpliPHI batteries are warranted off-grid. These generators can be warranted off-grid. And so this is a nice option for outdoor installs as well. And there's no derating for us. If you're using natural gas instead of propane, we've been able to adjust our ignition timing and really optimize these generators to provide that full power off of either natural gas or off of propane. We do have a commercial line of generators as well, and Sol-Ark has a commercial line of inverters that we will be talking about briefly. So our Power Protect generators as well, great for off-grid. We've got some demand response utilities and co-op partnerships in the works, off-grid power, and we can have warranty matches and on models purchased. So we've got a 1,000-hour warranty when used in non-emergency applications. So that would be like your off-grid generators. So let's talk a little bit about the Sol-Ark lineup. And I think, I'll turn it over to you, Quinn. I'll let you introduce these inverters.
Yeah, so we're going to talk about our main line of inverters, which is the 12K, 15K, 30K, and 60K. Our 12K is really your partial home backup. It's your 60 amp pass through. customers who maybe want to keep the Wi-Fi, their refrigerator running, hunters that need to keep. I mean, this is the same sale that goes into when you're selling a Briggs and Stratton, 10 to 15 kilowatt generator.
Yep.
Exact same style of application. The 15 kilowatt is the same. It's basically a transfer. Think of it as a 200 amp transfer switch that you can plug solar into, and batteries as well. It's a transfer switch that can pass full 200 amps, so a whole home backup. Can manage batteries, can manage an AC coupled source. Like if you have existing solar and you want to add batteries or want to add a generator to it, the solar can manage that flow between those multiple sources of power. And then when you get up to 30K, the main difference is now you're in a 208 native three-phase application. So this is for commercial buildings, 208 volt. You can also, if you want to wire a house in with three-phase 208 off grid, the Sol-Ark 30K could do that too. And then 60K, that's our native 480 volt inverter. So we've seen this be used for everything from off-grid EV chargers. We've got some powering off-grid, fleet applications where the utility power is limited and the customer needed to put in EV charging for some mandate. But any 480 volt application, all four of these inverters have very similar abilities to handle power transfer, abilities to two-wire start generators, integrations with monitoring. They're all very similar in their capabilities. They just scale based on power and the amount of mostly the amount of pass through. Another key point on the 12 and 15K, all of these inverters can be paralleled, so you can parallel the 15K and get a 208 volt application or a 240 volt three-phase application by paralleling three of those inverters. So if you really need something massive, you can parallel 10 60Ks and have a 600 kilowatt and a megawatt hour of storage if you're really getting crazy with it. But most of the people we talk to are installing 15Ks or 12Ks.
Thank you. And certainly you can parallel the 12Ks to produce that
Yep.
three-phase power if you want as well. 12Ks and the 15Ks. So let's talk a little bit. I've got an example here. Just talk a little bit about batteries, because most people realize that there's a capacity of a battery to hold energy, right? And that's the total amount of energy that will hold. We specify that in kilowatt hours. One of the things that I'm highlighting about the 6.6 battery is its ability to output that energy quickly, right? And just like a water-based system has plumbing and pumps, and there is a certain ability to deliver that water at a certain rate. Like you couldn't open your kitchen tap and expect to fill your swimming pool in an hour, right? The same for a battery. You can't expect to deliver all of that energy that's in a backup battery system in 10 minutes. And for similar reasons, right? The plumbing would burst. And so with that in mind, I did want to talk a little bit about sizing battery banks so that you can really take full advantage of the inverters. Now, with communicating batteries, we're going to highlight how the battery itself can dictate to the inverter how quickly it can be charged and discharged. And that can vary depending on temperature. For instance, if you're in a particularly cold situation, the battery can throttle back that temperature. If the battery's starting to overheat because it's a very hot day and you're drawing a lot of power quickly, the battery can keep itself safe by communicating that out to the inverter. So just quick words on this. We're going to be sending a slide deck out, but if you are doing a single Sol-Ark 12K inverter, that has the capability of providing 9 kilowatts directly from batteries. You can supplement that from the DC side with solar, but 9 kilowatts of draw out of the battery. So a single two stack, I'm sorry, there's a typo on the screen there. A single two stack minimum would be required to power a single 12K. If you have two in parallel, two 12Ks in parallel, you would want to have dual two stacks minimum, and then 3 12Ks in parallel. Maybe you're doing that three-phase power, for instance. You could do this with 2 3 stacks. Similarly, on the 15K, essentially one 15K inverter, 1 3K stack minimum, right? In order to be able to hit that full power output of that Sol-Ark 15K. And so 1-to-1 on the 15Ks, and on the stacks, these stacks are specifically designed to match that 15K Sol-Ark's power needs. If you're doing an installation, just a quick word on cabling with a Sol-Ark 15K. So a Sol-Ark 15K has dual DC inputs for the batteries, dual set of breakers there, and you want to make sure that you're landing on both of those breakers. So even if you're doing a single stack, we recommend double-lugged 1-aught battery cables, so 2 reds, 2 blacks, coming from a single stack going into each of those inputs on the Sol-Ark. And then if you're doing 2 stacks, obviously you would do 2 sets of battery cables, 1 from each stack. And you can use that Sol-Ark 15K battery input as your combiner. So that's a nice feature of the 15K, having those dual inputs and those dual breakers there, as you don't need a battery combiner, again, simplifying your installation. So I'm going to run back to these packages. I introduced these earlier, and I mentioned how using a Sol-Ark 12K can give you an approximate amount of battery backup time. And this is based on 75% of the loads in the home being backed up. So of that 1.23 kilowatts, you're backing about 800 watts up in the home. So the majority of the home is being backed up. You've got about 800 watts there. And if you have 800 watts running continuously on this 13.3 kilowatt hour stack, you're looking at about 14 hours of backup. And that's not based on a full discharge. So you could do 100% discharge and get a little bit longer. Similarly, on the whole home backup, we were talking about how now everything is going to be backed up. So you're looking at 1.23 kilowatts of power coming out of these batteries continuously. And you should get about 16 hours of power from that 20 kilowatt hour stack. Of course, you can have multiple stacks, up to 16 of these stacks with a single inverter. And there's no harm in having a very large battery bank and a smaller inverter. You just can't really generate maybe the necessary power, but you'd have a long backup time that way. So you can always add batteries if you want additional time.
And that's one of the, if you're selling solar and you're heavily you're familiar with the battery markets, that this is one of the main advantages of Sol-Ark and Briggs & Stratton over competitors like Franklin and Tesla and other AC coupled battery systems, which have the inverter built into the battery. We're able to separate the kilowatt hours from the kilowatt. So just like Nathan was talking about, you can have up to 16. Most customers aren't going to need more than 200 amp pass through, but they may need, if they want a week of autonomy, you could add Briggs & Stratton batteries for stacks and stacks and stacks to get hundreds of kilowatt hours to support that system. If you're doing a Powerwall or a Franklin or an Enphase system, you have to pay for the additional inverter capacity that may not be needed. With Briggs & Stratton, you can easily add multiple batteries at any time. So major advantage between, yeah.
Go ahead. I wanted to highlight that advantage. I mean, we unpacked a Franklin whole home, and that was my thought as well. I mean, one of the downsides to the Franklin is you got a 507-pound installation, right? And it's all in one unit. And if you have one problem with it, you have a problem with the inverter, well, now you've got a problem with your battery. You've got, you have it all in one unit. You want to add storage. Well, now you got to pay for all of those extra parts that you don't necessarily want. You might not necessarily need. Right. And so separating out the batteries from that inverter and having, instead of having an all in one unit, I think is the way to do it. And I really like this modular design. I also want to point out here that our PHI batteries are very easy to integrate in large systems. So both of these systems have 7 Sol-Ark inverters. The one on the left has 7 12K inverters. That's an installation up in Alaska. And I believe there are 80 batteries there. And I think there are 90 batteries on the installation on the right. You can't see everything. The inverters are inside an equipment room, but those are 7 Sol-Ark 15Ks powering that system. So when you're doing larger systems, you can do it with the lower voltage inverters. You don't have to go up to a Sol-Ark 60K or a Sol-Ark 30K, and you get some redundancy in having multiple inverters this way as well. So we do still see a good number of these installations. These both happened within the past 12 months. So let's move over to the wiring, and what we're looking at here is the front of a Sol-Ark 15K. You can see those dual battery inputs on the left side of the screen. What are the paralleling comms used for, Quinn?
Paralleling inverters.
Okay,
So
right.
when you're, yeah.
And the CAN bus port there is what would be going to batteries. What are we looking at in terms of our grid input here? So that's a 200 amp connection, right?
For 15K, yes, exactly. That's a 200 amp connection.
And that loads breaker there that we can see, that's also 200 amps.
Yep, 200 amp for the loads. And then for the AC coupling, it's up to I believe 90 on the 15K.
Okay. Okay. And I think that that gives you 19 kilowatts, I believe, of
Mhm.
continuous input on that. That could be AC coupled solar. That could be a smart loads output. That could be a generator input. If you're using that grid breaker in an off-grid situation, you bring the generator in through the grid port, and then use that generator port as a smart loads port. I can't think of why you would have AC coupling in an off-grid situation. But
Well,
then, yeah, go
we actually
ahead.
see that for customers who have existing solar systems, and then
Okay.
they want to retrofit and have a smarter inverter. So maybe they have, so for instance, again, I personally did one in California where the customer had another company install a Sonnen battery system with a solar edge as their generation capacity for an off-grid system, and he had a 24 kilowatt Briggs and Stratton generator, um, and wasn't getting the power he wanted. Didn't really work well, and so we came in, AC coupled his existing solar edge system onto the AC side, ran the generator into the grid side, and his system worked beautifully after that. So there are applications where that can make sense.
Nice, and thank you for highlighting that. Um, so on the top of the battery, the connections, the only real wiring you have to do on this stackable battery is really these home runs. The power output out of the battery controller. There's a grounding connection that's here that's not always required. It depends on your jurisdiction whether or not they want you to ground the battery, but then the communications cabling. So one of these cables is running out. This cable is running out to the Briggs and Stratton gateway. And then this second cable here is running through a dongle into the Sol-Ark. That provides that communication link between the battery stack controller and the Sol-Ark inverter, which is what allows the system to function very effectively and dynamically. With some of our other battery systems, what you want to be looking for, or if you just have multiple stacks of the 6.6 batteries, you will need to connect those batteries in a closed loop fashion. And that's you'll go battery to battery, battery to battery, and then one of those batteries will be connected to that Sol-Ark CAN bus port that you can see in the bottom right side of the screen, which is highlighted there. So we do want to make sure that we're running those connections, those CAN bus connections into the Sol-Ark inverter. And I'm also going to highlight here the ability of the Sol-Ark to control the Briggs and Stratton generators. And it can do this if you have communicating batteries. It can do this based on state of charge. It can run those batteries, allow those batteries to power those loads until those batteries get low. And then the Sol-Ark inverter can automatically start up Briggs and Stratton generators using the 2-wire start capability. So highlighting there the pins 7 and 8. And then I'm showing on the right side of the screen where you would make those connections on the controllers for the Briggs and Stratton home protect or power protect generators there. So I'm showing the 26K and then the 13K generators here. It's very similar connection. So other pinouts here, again, we're kind of highlighting some of these just so that you have this for reference. Of course, you can always look these up in the Sol-Ark manual. We do have built-in rapid shutdown into the Sol-Ark. We've got the emergency stop that's there. It's a normally open dry contact. And then that gen start relay that I just mentioned, that's a 2-wire connection, 2-wire start. And then the CTs. Now, I have heard that we should still use the CTs for the Sol-Ark 15Ks if we want increased accuracy on power coming from the utility. Is that the
No, that's exactly
recommendation?
correct. Yeah,
Okay.
even though Sol-Ark has an internal CT, the CTs provided and they're shipped in every package has CTs with them. Um, Provide some additional functionality around limited power to load, around time of use settings, and in general accuracy. So we always recommend that you install those, even if you're passing through the entire 200 amp service through a 15K.
And I believe you said that the 12K comes with 100 amp CTs included in the packaging, and the same thing with the 15K coming with 200 amp CTs.
That's correct.
So when you are programming a CAN bus enabled battery, if you're programming these communicating 6.6 batteries with a Sol-Ark, the setup becomes quite easy. There are some things that you do in the basic setup, enabling the screen timeout, for instance, etc. But once you get into the battery setup on the programming side of things, it's fairly easy to do. There's not a whole lot you need to do with communicating batteries. You need to check this BMS lithium battery, and the default there of 00 is fine for the SimpliPHI batteries. You'll put that overall capacity in the event that so that is communicated from the BMS, but in the event that you were to lose communications, you'll have that. Additionally, there's a number of settings that we can take advantage of here as well. And so one of the settings here is also for display, whether you want the percentage of the overall battery or you want the voltage to be displayed. Most of the customers will choose a battery percentage. And so that will be either, whichever one you choose will be the one that would be illuminated here, not grayed out. You also have the ability to choose charge from generator and enable grid charging, and there are some settings associated with that. And once you hit these values of 30%, for instance, if you had the generator charge button checked, it would start up that generator and go through a charge cycle. Another thing to point out here is that the Sol-Ark inverter gives you the option of exercising the generator. And so you can set that up when you want that generator to exercise. We typically do this once a week just for 60 seconds. One last thing that does need to get programmed in when you're setting up the battery settings is the battery bank's overall resistance. And what this allows you to do is when the system is discharging and you're under load, it does allow you to go below the low battery cutout voltage. So let's say, for instance, your low battery cutout voltage was 47. If you have a certain amount of battery resistance in there and you're drawing a heavy load, some of the overall voltage of the battery bank is lost internally. So we call that internal resistance. And so you might see the inverter run to voltages below what you've programmed into your low battery cutout. And that's simply because the resting voltage is actually above the loaded voltage of the battery bank. And so I've given the numbers there to put in. That's 15 milliohms. And then it decreases by the number of batteries you have. So if you have a 3 stack, it would be 15 divided by 3. There's the option to do, and actually, Quinn, I think I'm going to let you talk us through this, but there are many options with the Sol-Ark in order to limit the amount of power to your home, for instance, or do time of use setup, or how much power you sell back to the grid from your solar, for instance. Gwen, would you talk to us on this slide here?
Yeah, I mean, we have 5 hours of certification programs that you can get into the nitty gritty on how you can get into this, but you can do things like discharge from your battery. So, for instance, if you're there's some really lucrative VPP programs in various parts of the countries where they want to send signals and have your batteries discharge, or they want to you're compensated really highly for energy during certain times of the day, and so you want to be selling from your battery to the grid at certain times. There's also, you want to store energy in your batteries for, before night or before a potential outage. So you have full options of changing how much energy you store in each of these by time, how much energy you're storing in your batteries and how much energy is being discharged. And this grid cell is part of the PCS that I was talking about, where you can limit the amount of energy that's going back into the busing of the main panel without damaging that busing or violating the 120% rule. So there are many different configurations, and if you have specific questions, feel free to shoot them in the chat, or get a hold of our tech support. We've got great tech support, again, stationed in Texas, but there's frankly more potential ways you can set up this system than I can possibly go over.
So I'd like to
So
give you a
if you have
chance to
specific
actually
questions,
plug Sol-Ark University here. Do you want to talk
yeah.
just for a minute about your training programs?
Yeah, so we do. We have a really great training program. We're actually rolling out a new learning management system actively. I think that is either just launched or will be launched in the next couple of weeks. Um, but a much more detailed certification program. Sol-Ark University is a series of training videos where you can get certified and become a certified installer. It's about 5 hours of classes. We also offer webinars. John Cromer, if you are at all involved in Sol-Ark social media, John Cromer is a really great resource. Is our head trainer and is normally the person who's on calls like this, but I'm stepping in because he has a conflict. But Sol-Ark University is a really great resource that our training department has built to answer any of these questions and make sure you're prepared for your first installation. But again, don't. It's a complicated product. It's easy to install, but the commissioning and the programming is takes some repetitions. So don't be afraid to call tech support. We answer very quickly and can help you program this thing and make sure it's set up just how you want.
And thanks, Quinn. And I will mention that Briggs and Stratton also has a Power Academy, and we have courses on there where you can learn about batteries. You can learn about generators. And I also want to highlight that both the Sol-Ark training program and the Briggs and Stratton program, these are free services. You don't have to pay for these certifications. So I will highlight just a little bit about the telemetry you'll get through the gateway, and this is called Energy Track. It's our monitoring platform. You get system level views of your individual batteries and your stack controllers through this platform. It also allows us to give you over-the-air firmware updates, and our gateway allows our tech support team the opportunity to troubleshoot. If you're having trouble with your commissioning process or you're not sure if you've got things set up right, it gives us an inside view. You'll, of course, have access to, again, the free Sol-Ark app for monitoring as well. You can pull the battery information from that app as well. So we're looking at a real system installation here. We're looking at battery information from that particular system. And you can see you get a lot of information about your battery bank as a whole. We are complementing that with Energy Track by giving you individual battery module level monitoring on the Briggs and Stratton side. So you can see information here, graphs, your temperature, your overall capacity, your charge discharge window. Here we're looking at a month view, looking at the number of kilowatt hours that are coming on different days of the month. We're looking at the different inputs of power there. So we've got PV power here. We've got load. We're exporting a little bit from this system. It looks like export is quite limited. It's mostly self-consumption here. And then there's some import as well. Discharge and charge you can see on a single screen. What are we looking at here, Quinn?
Yeah, so this is that off-grid system I was talking about with that well pump. So what you can see is that in early morning, he's got some battery state of charge, about 75%. That's getting him through the morning loads. You can see his little spike at 5 a.m. is starting to make his coffee. And then at around 8 a.m. on the 24th, maybe a little earlier than that, maybe about 6 a.m., they turn on that well. And so you can see the state of charge, which is the green line, just take a nosedive as that well starts working through the battery energy. And then that battery gets down to that predetermined 35%, kicks on the generator instantly recharges the battery, and then it goes, once it reaches 75%, which is when he has his cutoff, it's the generator stops charging. You can see the battery state of charge goes down a little bit as it continues to support the well, and then the rest of the day is solar is going to recharge those batteries. And I wanted to also highlight, this is another day where a very similar thing happened, right? Battery state of charge got low. So they turned on the generator, recharged the batteries, turned on his well pump. This one, it looks like he knew he was about to turn on the well pump, and so he exercised the generator manually before turning on the well pump. So he had a little bit of juice in his batteries, and then ran his well pump, depleted the generator, or depleted the batteries, and then the generator triggered and recharged the battery. So I just wanted to demonstrate, again, this is a customer who's fully off grid. He's been off grid for, I think, 40 years. And this is the first time that he has had a system that's able to uh, automatically trigger the generator and run off the batteries in order to support his well pump. And he likes fiddling with it, but he's very impressed with the system so far.
That's awesome. We're looking at an AC coupled system here. So this is an example where you can see that PV come on during the day. You've got micro inverters that are there. So that's that AC coupling I was talking about. This is a system where customer is trying to do self-consumption and time of use. So as micro inverters come on, you'll see that battery percentage start to increase. That battery percentage gets saturated there. And then that solar continues to power the loads in the home. And so there's very little import from the grid in this type of system. I'd like to highlight the fact that the Sol-Ark app is easily able to detect these different power inputs. And it does that naturally, even with generators, I believe, right, Quinn?
Yeah, it has the ability to, based on the either based on where that generator is landing or the total harmonic distortion of the generator, is able to differentiate between a generator and an AC coupled source like a microinverter.
Thank you. We're looking at another example here where we again have microinverters, and you can see those loads creep up. This might be an air conditioning unit. This is a Sol-Ark 15K, and you'll see that this is peaking out around 9 kilowatts of power. Given that the a in the US is a little over a kilowatt for a 24-hour period, 9 kilowatts is a fairly significant load for a home. But that Sol-Ark 15K was able to handle that quite easily, and with a decent amount of solar coming in, we still see these batteries continuing to charge up throughout the day so that they can be discharged at night. One last feature, I know we're just about out of time. We've got just about 4 minutes left. You may or may not know about the challenges all lithium batteries face with charging up in cold environments. And what ends up happening inside the cells is that the lithium has trouble getting into the graphite layer inside the cells in cold temperatures. And sometimes if you charge too quickly in cold weather, you can get these solid lithium deposits, which are called dendrites. That just means branches. Rapidly charging in cold temperatures continuously with time can lead to even damaging the cells and puncturing that the layer in between the cathode and the anode. And so one of the things that we can do with communicating batteries is that we can reduce that charge rate automatically with that battery communicating out what rate it would like to be discharged or charged at. And I'm showing here our SimpliPHI batteries. These batteries have different charge discharge rates and limits than the new 6.6 batteries, but it's the same kind of idea. Another thing you can take advantage of with these batteries, so again, both of our batteries are able to discharge at reduced rates, but down to significantly lower temperatures than the competition. And you can utilize that internal resistance to actually act as a battery heater in low temperature situations. If you do need battery heaters, again, both the SimpliPHI and the Phi batteries, we can integrate these heaters, which do get powered off of a critical load support. Here's an example of installations with Sol-Ark and Briggs and Stratton battery cabinets. These are Boss 12, Boss 6 battery cabinets with heaters integrated and Sol-Ark inverters. This looks like Sol-Ark. Are those 12Ks, Quinn?
They look like 12Ks. It's hard to tell, but
yeah,
sure looks like
I think I see the fans on the side. And so this one's in Buffalo, New York. So as we end here, I want to give a little bit of time for Q&A. I haven't been checking the Q&A as I had hoped to. We do have an installer program, and currently, right now, I think through the end of June, we've got $150 cash back per battery. So it's above that $100 cash back that's shown on the screen for our elite installers. So if you do want to join our elite installer program, we also have $1,000 cash back on your first ESS system installed. So you purchase a Sol-Ark inverter, purchase those batteries, and we'll get you $1,000 rebate on your first Briggs & Stratton installation. Um, both both of our teams, training at Sol-Ark and energy storage training at Basco, are happy to take questions. And then if you want to give some to us right now, we'll answer those as well. So Quinn, I'm going to jump into the Q&A. Alberto Pez says, what's the battery max discharge current? It does depend on which battery we're talking about and how big of a stack we have, Alberto. So for a single 6.6 battery, we're looking at 130 amps of maximum discharge. For a stack of 3 batteries, the controller does limit the maximum current output a little bit to 273 amps. That's right at that 275 amp maximum input of a Sol-Ark 15K. So hopefully that answered your question. Feel free to email us if you need further clarification. And yes, it is continuous. Yes, Alberto, that's a continuous output current from those 6.6 batteries. And again, one of the reasons we're able to do that is we've made some changes in our technology with improved electrolyte and have that ability to discharge quite quickly. So I don't see any other questions coming into the Q&A. Quinn, I want to thank you for taking the time to be on here with me. Do you want to add any last words here?
You know, I really encourage anyone who's interested in the product or getting interested in really the thought of, I don't know if most of your backgrounds are coming from generator installers, but if you can think of an inverter as a transfer switch that can handle additional sources of power, it really becomes a very simple thing to integrate into your business process. And you know, batteries are expensive, easy to install products. So as a contractor, that markup and margin becomes very real, and it has very real benefit to your customer. So if you have any interest in offering them, get involved, get trained on the products, and it can really be a boost to your business and a differentiator. So
thank you.
that's all I got.
I appreciate it. I really appreciate you taking the time. We are out of time. If you do have additional questions, feel free to email us. Once again, energy storage training at basco.com and training at solark.com. Thank you, everyone.
Thanks, everybody.